Hello guys, in this video I'll show you how you can build your own completely local agentic LLM with tools. In this video you will create an example project of lunch restaurant assistant. The assistant will help us select the restaurant based on the lunch menus. But before we start building the thing, let's first go through what agentic LLM is and how it works, what are the parts it consists of, so we have the big picture in our mind when we are building the thing. So here is illustration of agentic LLM. Let's start from the tools, which are the key part of the whole agentic LLM. In here we have three different tools which we are building shortly in our example project. One of which is the current date tool, and then get nearby restaurants tool and fetch URL tool. These tools are then registered to the tool registry, which holds the information about the tools. And then when user prompts us the question that, hey, I would like to have some spicy today but not too heavy, we combine the user and system prompts. So we have the system prompt which gives the LLM basically a persona of a restaurant expert, and then in addition to that there is this information about the tools that are available for the LLM to call, and then we combine that with the user prompt. Then we send the system prompt with the user prompt to the LLM, and in this loop we stay as long as the LLM wants to call a tool. So if the LLM wants to call a tool to get additional information, we will make the tool call and then provide the information back to the LLM and iterate this loop until the LLM does not have any tool calls it wants to make anymore, and then we basically get the output as a result. In our case, the output would be a recommendation of a restaurant where we would like to visit for lunch today. So let's start building. I prepared already a couple of different menus for us for use. So we have 4 restaurants from Helsinki area, and here we have the URLs for the menus. And this first one is a bit different. It is a JSON-based API. And then rest of these are basically links to a web page containing the menu for that given restaurant. For example, here it's on the page next to other content. Here are the menu URLs. So let's start building the first tool. As in first tool, let's build the simplest one, which is the get current date tool, and this tool doesn't take any arguments and it returns the current day or date as a string format. And here we just get the date today and cast it as a string and then return the value. For each tool we want to have a docstring which describes what the tool does. We will go this in more detail shortly, that how we will utilize this information, but we want to basically describe for the agent that what this tool does, how it can be used, and so on. So in this case, get current date is, I think, sufficient to describe the tool and how it works and how it can be used. And for each tool, let's also add a print calling get current date tool, and this is just for us to kind of see when the model calls and what tool it uses. And here we have the first tool already implemented. So next, let's make the get nearby restaurants tool. In this case, we will use the fixed lists of restaurants that we just saw in the beginning, but in practice you could build a database of restaurants and then query based on example user location. But just to keep everything simple, let's use the static list. So for this, let's import new types. So we will need import dictionary and then list. So get nearby restaurants tool. This doesn't take arguments either, and this returns dictionary of string, and then the value is list, and then the list contains dictionary which has string value. So that's the type, and then this function returns the dictionary which has key restaurants, and then the array of dictionaries, and then each dictionary has a key name, and then lunch menu URL as another key, and then the value here. And then we can just copy paste this four times. Why we want to return the dictionary instead of just the list of restaurants is that since we are playing with very limited context with the tools, we can give a lot of information for the LLM or context that with this one single word that what this actually is the response. Otherwise there wouldn't be a lot of hints that okay, the tool name suggests and the docstring that we will add shortly that okay, this tool returns list of restaurants, but the result itself doesn't contain that much references to restaurants. And if we would like to add this restaurant, let's say restaurant name, then we would duplicate the same string into every value, which then would increase the context that we will pass for the LLM. So kind of keeping the unnecessary repetition out from the response, keeping it simple and straightforward. So here we want to just basically copy the values, and then the lunch URLs as well. Yes. And now let's add the docstring get nearby restaurants and their lunch menu URLs. And then let's have the print so we can follow. Calling get nearby restaurants tool, and then we are done. And the last tool that we are still missing is the fetch URL tool. So for that let's import requests and beautiful soap. And then just get a fetch URL tool. So this tool is different from the others. So this gets the parameter, which is URL and its string format, and then response or result return type is also string. So first we want to make the request to the URL. So requests.get. So we only want to allow get requests, but of course you can make your own tools to support that use case as well. But in this case we are keeping it very limited. So when we have the response, we want to check that if response status code is 200. Basically if it is, we want to then use the beautiful soap and response.text. So why we want to use the beautiful soap is that when you access this URL, we can see that since it's whole website, there is a lot of different things that are not interesting for us. Example, the header and then images, other content. There is so much stuff in the response. So how we can ease up the work for the LLM and limit the amount of data we pass to it is that when we get the status code of 200, we pass the response text to beautiful soap, and then we try to get the body out of it. So basically with this we can see that if the body is found, we know that it's HTML, page, and the body is usually containing all the information that we are looking for. So all the JavaScript, CS, and all the stuff in the header and other place in the HTML template are completely dismissed. And then if the body is not found, we can in this case say that it was JSON response or other type of payload. So in this case we kind of expect it to be JSON, and then we can just use that as it is. So if body is found, we return body.getText and then strip. So if the body has some trailing or preceding white space, we remove those and simplify the response even further. Then the body is not found, we will just return response.text. And then else, if the status code was not 200, we will return a string saying error, and then we can here say the response.status code and then response.text. So we will have some information that what went wrong. Then if the try fails, so there is some beautiful soap issue or anything else, we will also return an error string and then just have the error there. And then this is all. Oops, yes, beautiful soap, not soap. Yes, now it's working. So that's the fetch URL tool. So now let's add the doc string for it. And for this we can just say that makes a request to the given URL and returns response in a string format. The param URL is the URL to be fetched in string format, and then return is the response in string format. And then let's add a print here that gives us some insight. So calling fetch URL tool, and then let's add the URL as well. So now we get some idea that how the tool gets used and what URLs it's calling to. And to see it in action, we can just call it tool and then like this. I had still some typo. So we can see that this was one of those web pages which had the menu in them. So we can see that it basically got the body and there is no HTML tags or anything else. Some row changes, but those are fine in our case. And then this menu with the JSON, we can call it as well and see that it works very well with that as well. So then we have all the tools created. So the next thing is to create the tool registry, which is basically a dictionary. And here in this dictionary we have a name of the tool and then the tool callable itself. So example, get current date, get current date tool, then get nearby restaurants, get nearby restaurants tool, and then get fetch URL tool, and then fetch URL, and then fetch URL tool. So now we have the tool registry created. The next one is to create the system prompt. I have one already prepared, so we don't need to write it from scratch. Here it is. This basically has the items that I mentioned earlier, that it gives the persona for the agent, that how it should work, what we are kind of expecting from it, and what tools are available for it, and so on. So here we say for it that you are a restaurant selection specialist whose goal is to help the user pick a lunch restaurant that best matches their needs. Compare menus for multiple restaurants and pick the most suitable one. You have access to the following tools. Here is a tool string which we will fill in shortly. And when you want to use the tools, reply with exactly one line and nothing else in this format. And this is the format that we are expecting it to use. And then basically it's telling that use the single line JSON double quotes format. And then when the tool is finished or has finished and it returns the response, we tell that in which format it should expect the tool to respond, and then continue the task and reference the tool result, and then if no tool is needed, respond normally. So basically this happens when the LLM has all the information it needs to be able to answer to the question that we had. And then just a small detail about how it should give us the final output is that deliver the final recommendation with just the restaurant name and the menu that it has in the current day, and then we remind it once more that don't guess things but instead use the info provided by the tool. So try to avoid the hallucination over here. And this is especially important in our case because in this example we are using the QWN3 8 billion parameter model, which is small enough to run locally, and there is some risk for hallucination, so it's important to kind of remind it to keep strictly in the facts and then have also very precise prompt how it should behave. But this is the system prompt and you can tweak it around if you want to see how it affects. And after we have the system prompt, the next thing is to basically form this tool string that I mentioned just a moment ago. And for that we will use inspect and then some new typings from typing import callable, and then this tool string we basically loop the tools through and then want to extract the name, how it's called, and then the description for each tool. And then for that, let's create a couple of helper functions. So first one, def get tool string. This is for one singular tool. So we have the tool name as a string format and then the tool itself, which is a callable. And then this returns a string output. Yes. And then what we have for each tool in the string, we will have a name, description, and then the signature. And name is very simple, it's just a tool name. The description, it's the doc string which we created, and then signature, here we want to use the inspect, which then allows us to get the signature of the tool. And when we add the F in the beginning, now it looks good. So this is the info that we will gather from each tool and provide for the agent, so that it can understand kind of the tools a bit better which are available. And then we have the get full system prompt, which takes the tools in it. But this is basically a dictionary of string and callable, and then this returns a string as well. And here we create the variable of tool string, initiate it to be empty, and then for tool name we loop the tools through. So with the items we can get the dictionary to be a list of tuple of key and value, and then we can just get the or fill the tool string with the get tool string, tool name, and then the tool. And then between each tool we want to have some separation, so we will just have a new line, and then 15 of equal signs, and then new line in the end as well. And then how this basically looks: return system prompt format. It was tools string, and here we have a tool string. So when we call this get full system prompt tool dictionary, registry, we get the prompt as we saw, and then in the prompt we can see that the tools are filled in. So example, here we have a get current date, then the description of get current date, and then signature is the Python signature, how it can be called. So now we have the tools created, tool registry created, and system prompt filled. So now next thing which is missing is the extracting the information when the LLM wanted to call the tool. So for that we will create a new helper function, and for that we need new types, import tuple and then import JSON, and this is extract tool calls, and the text will be the text that the LLM generated, and then this function will return us the list of tuples. Each tuple has the tool name and the arguments that it wants to call. So technically the LLM could call multiple tools at the same time in a row. And then as said, the return type is list. Each list item is a tuple, and then here we will have a string, which is the name of the tool, and then dictionary, which are the arguments for the given tool. And then here we just create a new variable tool calls, and then for line in text dot split lines we will check that if the line or first we strip the line. So in the case if we would have some white spaces, let's throw them away, and then we can just check if line starts with we said it should call the tool with this syntax, so we can check that if it started with that. And if it does, then we can continue. Actually, we can use the note here, so we can just continue. So if the line didn't start with a tool, then we can say that it was something else. We can discard it. And then if it was starting with tool, then we can proceed with the additional parsing. So here, let's wrap this into try catch or try except. And here we want to have the tool semicolon extracted. So line length of this and so, and then let's strip this as well. So basically we get everything after the tools, since we said that have the line tool semicolon, then the space, tool name, and then arguments. We can get the name with the after dot split, and then the opening parenthesis. So what this basically does, it gets this section and then rest of it splitten. So we have the name and then the rest, and then name might have some white space as well. So let's do the strip void and then get the arguments, which is basically the JSON string. We can have rest dot split. Let's split from the closing parenthesis, then get the first item out and then strip as well. So this basically gets us this. And then we can create a new argument of args, and then if JSON string, so if there was some result from the split and strip, it means that it had some arguments in the tool call that it wanted to use, and with it I mean the LLM. So if JSON string is existing or truthy, we can then just set args equals JSON dot loads JSON string. Why we want to check the existence of JSON string is that otherwise this JSON loads would fail, and then we would need to handle the case a bit differently, but I think this kind of keeps it simple. And then we can just append the tool call, and then here we would just use name and args. So in case the arguments wouldn't exist, then this default value of args would be in use. And then regarding except, let's print error, and then the e, and to get that, let's get it out and then continue. So if something happens, we can just report that error happened and then continue. Most likely the output from the LLM or tool call from the LLM was malformed and there was something that we didn't expect. That's in the sense fine in this case. And then in the end we want to return tool calls. So here we have the extraction tool for the agentic loop to get the tool calls. Now we have the way to extract the tool calls. So next thing, we can create the helper for calling the LLM. So in this case, the QWN model is run on Ollama locally on my machine. So for that, we will create a helper tool or function to make the call. And for connecting to the Ollama, in this case, I'll use the OpenAI library. So from OpenAI import OpenAI. Why I'm using this is that this OpenAI library allows us to use this nice conversation messages model, which allows us to keep data in the more readable form. If you would use only the raw HTML calls, the Ollama REST API, then we would need to always gather everything into the string payload and then extract items out of it and kind of keep the code nice and clean. This helps for that, and also it's very nice to use. So how to use it is that first we need to form or initiate the client, and for that we just need the base URL, which in my case is this, and then the API key, which in this case, since there is no API key in my local LLM, we can just write Ollama. It is discarded anyway, so you can write anything there. So now we have the client configured, and then we want to create the function. So generate answer with Ollama. Then here we give the conversation, which is a list of dictionaries, and each dictionary has string keys and string values, and then a response from this is a string. And then here we can just print thinking to give us some idea that when the call to the Ollama started, and then very simple try catch loop. So let's get the response from client.chat.completions.create. So this is the call to the model. So here we specify the model, which is the key when 38b. Then messages is the conversation, and then the stream is false. In this case, we want to keep the streaming false signs. Otherwise, we would need to handle the streaming of the tokens. But with this, we can keep the solution a bit simpler. But for user, it would be nice to see already the answer when the first token's gonna hit, so it kind of feels that or keeps the feeling that the system is very fast, even though it's as slow as it would be otherwise. So in this case, we have the response already. So we just return response.choices. From choices, we want to get the first one, and then message.content. And then if something happens, exception as E, we want to just print an error that something went off. It could be that, example, the local model didn't start up or something. There is like some issue. So just to get the idea if something like that happens. And now we have that. So the last thing is to create the agentic loop, which was the tool call agentic loop. And for that, we create run agentic loop, and no parameters for this. And then just to start up the discussion, since these LLMs will only answer when you ask something from them, we can have this hard-coded string here to push the user to ask the first question. So it could be, hi, what would you like to eat today? So a simple question which the user most likely wants to answer to. And here we first initiate the conversation object or variable. So list with only one dictionary, and each dictionary basically represents one message. And each message has a role, which in this case is system, since this will be the system message. And here we will call the get full system prompt, and it was tool registry, which we wanted to call. And this basically sets the initial message for the agent to contain the role and that stuff which we went through a moment ago. And when we have that first message set, we want to have the first while true loop. So this loop is the loop where the user may ask questions or give additional information for the agent. And here we want to get the user input, so answer to the first initial question, which is the lunch preferences, and then accept if there is keyboard interrupt or EOF error, we can then just break the loop. So if Ctrl+C, for example, is pressed, then we want to check that if user input equals quit, user can quit with that as well. Then now we know that user asked something and they didn't want to quit. So we want to add the message to the conversation. So conversation.append. Let's add the role to be user, and then content to be the user input. And then we want to have a second while true, and this while true is the LLM tool loop. So this while true runs until the agent does not want to call any tools, but instead wants to ask, let's say, additional information from the user, or has the result for the restaurant in this case. So here we want to get the generate answer with Ollama, and then this gets the conversation. So first we get the answer from the LLM. I think I typed this correct. Yes. And then from that LLM response we want to get the tool calls. So tool calls, and it was extract tool calls. And then if tool calls exist, then we want to continue, but we can again do this early return. So if no tool calls, we want to print the response. So the assistant said LLM response. And then in addition to that, we want to add it to the conversation loop. So conversation append, like this, and then role is assistant, since the assistant create the message, and then content is the LLM response. And then we want to break this. So when we break the loop, the user will get the new input field, and if assistant want to ask something, then the user could answer and then continue the loop. So if there was some tool calls, we want to get the for name and args from in tool calls, and in this case first we get the tool, so tool registry, then name, and then response. So this response will get the result from the tool, or we will save it here. And in this case, since we have just fixed amount of tools, very simple tools, we will hard code the tool calling here, but in more complex systems you might want to do some dynamic or more dynamic approach. But in this case, basically we check that if the name is get near by restaurants. We set the response to be the tool. Tool without the args, since we know that that tool doesn't want any arguments. Then if the name is get current date, then we'll do the same. So no special handling the either or passing the arguments. And then lastly, if the tool call is fetch URL, then response is the tool with the args. So now in this case we pass the arguments to the tool. And then in the end conversation dot append, we will append the results. So role is user, we can use that, and then content is the tool call content in the format which we said it would return to. So in this case it would be f starting with this and then like that, and then f string and json dot dumps response, and that would be it. Oops, there was a typo. And now we can call the agentic loop, and like this. I would like to have some pasta today, and let's kick it off. So now it's thinking. So LLM started by calling the current date tool. Let's see what it will do next. And now we can see that after the date it fetched the nearby restaurants, and maybe we can soon see the LLM to be fetching some restaurant lunch menus. So as we can see, the LLM called the fetch URL tool, and since there is no thinking between, we can actually also say that it formed a tool call where it called the same tool with every lunch menu URL it had. And now we fetched the URLs, provided the menus for the LLM. Now is thinking and choosing the restaurant to go. And with this, if you allow multiple tool calls, as you can see, you can speed up the process so that, example, in this case, we have 4 restaurants, so that the LLM doesn't need to one by one call the restaurant lunch menus, and then every time between the calls think a bit and then launch the new tool call. Otherwise, it wouldn't be that big of a problem, but since we are running the models locally, the model is way slower than hosted in the cloud. So in this case, it speeds up a lot. Okay, now we have the result from the LLM. So it proposed the restaurant boundary, and here is the restaurant lunch menu. And actually there is no pasta in the menu, I think, but in any case it sounds delicious and would be a very good place to go. But I think even if we didn't get the good answer from the LLM, in this video we could build the system and call the tools, and we could see that the LLM actually worked with the tools. So I think this is just a limitation of the model itself. And I think that's all for this video. Hope you liked the video. If you have any questions, comments, drop down below the video. And if you liked the video, leave a like, subscribe to the channel, and see you guys in the next one. See ya!